Hot take. The fastest vector store benchmark can be the worst choice for your RAG system.
Exactly. Because a benchmark that measures only speed can reward the engine that returns the wrong context, the wrong documents, or results that collapse under real filters.
So this is not really about leaderboard bragging rights. It is about whether your assistant answers well in production or quietly starts lying.
Right. A good vector benchmark should measure the whole retrieval job: relevance quality, latency, filtering behavior, throughput under load, index build and update cost, memory footprint, and operational stability.
Give me a concrete failure. What does a bad benchmark miss that hurts a real team?
Picture a support bot for a SaaS product. The query is fast, maybe 10 milliseconds. But the store misses the latest billing policy doc, ignores the account tier filter, and returns articles for the wrong region. The user gets a confident, wrong refund answer. Low latency, high damage.
That is the tension, right? Fast retrieval feels good in a dashboard, but bad retrieval shifts power to the wrong system. Your generator improvises, and now the benchmark winner creates the production loser.
Yes, latency matters, but only after you know the retrieved set is actually useful. In practice, you want metrics like recall at K, precision at K, maybe NDCG, and task level success. Did the right chunk appear high enough to help the model answer?
And not just in one clean query pattern.
Definitely not. Benchmark across realistic query types, short keywordish questions, messy natural language, multi-hop prompts, vague user phrasing, and updates to terminology over time. Retrieval quality often looks great on tidy prompts and weak on actual user traffic.
Let us talk filters, because a lot of demos conveniently forget them.
Filters are where many benchmark stories fall apart. Real RAG systems rarely search the entire corpus. They filter by tenant, permissions, product line, language, geography, document freshness, or source type. A store can look amazing on pure nearest neighbor search, and then slow down or lose relevance when metadata filters are added.
So if I benchmark without filters, I might be testing a world that does not exist.
Exactly. Example: an internal legal assistant may need semantic search only within contracts for one business unit, in English, signed after 2022, excluding archived drafts. That compound filter changes both performance and quality. If the benchmark ignores that, the result is strategically useless.
What about the dataset itself? People love synthetic corpora because they are neat and easy.
And often misleading. A good benchmark uses a dataset that matches real document shapes, duplication levels, chunk sizes, metadata density, language mix, and update patterns. Synthetic text with evenly distributed topics and perfectly separated classes does not behave like product docs, tickets, PDFs, chat logs, and versioned policies.
Why does realism matter that much? Distance is distance, right?
Not in messy corpora. Real datasets have near duplicates, boilerplate, stale versions, sparse metadata, long-tail entities, and ugly OCR. Those conditions change index behavior and retrieval quality. The store that wins on clean synthetic vectors can fall behind when the corpus has 10 similar release notes and only one contains the actual breaking change.
So now we have quality, latency, filters, and realistic data. What else belongs in the benchmark if you care about production, not theater?
Measure ingestion and mutation. How long does it take to index new chunks? What happens when you upsert frequently? Does query quality drift during heavy writes? Also test concurrency. One user at a time is a lab toy. Real systems get bursts, retries, and mixed workloads.
That is where winners and losers separate, because the benchmark can change who gets chosen for the whole architecture.
Yes. Example: a team benchmarks on 10,000 documents. No filters, single-threaded queries, and static data. Store A wins. In production, they have 20 million chunks, tenant isolation, hourly updates, and 50 concurrent sessions. Suddenly, tail latency spikes, recall drops under filtering, and the re-ranker has to work overtime. The cheap benchmark caused an expensive migration.
You said tail latency. Why not just average latency?
Because users feel P95 and P99. Average latency hides stalls, cache misses, and pathological queries. In RAG, one slow retrieval can blow the whole response budget, trigger timeouts, or force the app to answer with partial context. Benchmark medians if you want, but trust tails more.
I also want one practical benchmark recipe. If a programmer is building a RAG app this month, what should they actually do?
Start with a held-out set of real queries and judged relevant documents, even if the set is small. Run each store with the same embeddings, same chunking, same top K, and the same filters. Measure recall at K, NDCG, P50, and P95 latency, throughput under realistic concurrency, filtered query performance, memory cost, and time to ingest updates.
And keep the test close to the application, not a generic search contest.
Exactly. Example: if you are building a docs assistant for developers, include version filters, language filters, and tasks like migration questions, where the right answer lives in one updated page among many outdated ones. That benchmark tells you whether retrieval protects correctness, not just whether a query returns quickly.
So the anti-patterns are clear: vendor scorecards, marketing screenshots, and toy synthetic tests that never meet a user.
Yes, those tests optimize for appearances. A good benchmark optimizes for decision quality. It tells you which store helps your generator answer correctly, consistently, and on time in the world you actually operate in.
Which means the benchmark is not a side quest. It is governance for the most failure-prone part of RAG. That is the point.
If your benchmark does not look like your workload, it is not measuring retrieval. It is measuring how easily you can fool yourself.